everyone, it's your boy Raid coming at you live from my basement. You might notice that my voice sounds kind of different, like I sound kind of congested and kind of hoarse, kind of raspy. That's because I got COVID-19. Yeah, not been doing too well in that department. Besides that, I've also been really tired, not been getting good sleep because I'm very jet lagged. Just got off a 16-hour flight, been on a long trip abroad, so my sleep has been pretty bad. And alongside all of that, I've also been recovering from a mysterious stomach illness. I'm mostly over that, I just hope it doesn't come back. So despite this triple whammy of afflictions, I'm still making this video for y'all. You might be wondering why that's the case, why the fuck I'm still making this video for all of you. And that's cause I really wanted to do it. So, you're fucking welcome. I only wore glasses for the thumbnail because I thought it would make me look smarter and help me get more views maybe. I don't actually wear glasses, so won't be needing you anymore. I'm also sipping on this beer cause I'm trying to do this whole thing unscripted. When I am a little buzzed, I'm a bit more eloquent, and I think I'm going to need this. So, cheers. Jesus Christ. Beer does not soothe the sore throat. Just putting that out there. Okay, let's get down to brass tacks. In this video, I, a musician, a pianist, drummer, and now guitarist, and sort of producer, will be dissecting Synthesis by tn-shi. I hope I'm pronouncing their name right. I'm just gonna stick with tn-shi because I don't know if that's the correct pronunciation for their name, and I'm too tired to give a shit about anything. This video is for all the non-musicians or beginner musicians who saw the video for Synthesis and were like, wow, this is a really cool tune with a really cool music video. But I don't really understand what's going on because there's a lot of numbers and symbols and everything is flashing and flying around so quickly. And it's so confusing and I just don't get it. I'm here to break it down for you. I'm here to make it not so confusing. I'm going to explain everything to you. And maybe after watching this video, you can go back and watch the video for Synthesis. And you'll have a new appreciation for everything that's going on in the video. You'll rewatch it and be like, wow, that wasn't so confusing. This is actually pretty cool, and even cooler now that I understand what's going on. That's my goal with this video, to break down all the stuff that's going on in the music video so that you understand it the next time you watch it. Alright? First things first, before we begin the video, I'm going to assume that you, the viewer, have a basic, very rudimentary knowledge of scales, chords, and how to read and count rhythms. If you don't have a very basic fundamental grasp on these three things, don't worry. I'm going to put two videos in the description and show their thumbnails right here in this video and recommend that you watch these. These are like your required reading. They are Andrew Huang's Intro to Music Theory and Ted Ed's Guide on Reading Music. So if you need to, go watch those videos and then come back to this one. Those videos will get you right up to speed with everything, all the concepts you need to know before tackling this video. So go watch those videos first, if you need to, and then come back here. Alright? Now, without further ado, let's break down Synthesis. We're just 4 seconds in, and we've already struck gold. Jesus. Listen to this. That is the main melodic line of this tune. That is the main motif, the main musical idea that ties everything together. What you're hearing is a square wave with a little bit of reverb and delay on it, playing the main melody of this tune. When I say square wave, I mean it's one of those fundamental basic wave shapes that almost all oscillators are capable of outputting. It's a very distinctive sound. It's very crisp. It's got a lot of high-end content. If you've played any video game ever or listened to any video game soundtrack ever in the history of video games, you have heard a square wave before. And when I say reverb, I'm talking about a sound effect that makes a sound like it's being played in a cavern or in a big cathedral or big church hall. It gives a sense of space. It makes the sound ring out a lot more. Here's what a square wave sounds like with reverb on it. And when I say delay, I'm talking about a sound effect that causes a sound to sound like it's echoing, like it's being played back over and over again. Here's what a square wave sounds like with with delay on it. You hear how it's echoing, alright? Now I'm gonna play a square wave with both reverb and delay on it. And you notice how that sounds exactly like what we're hearing here. Alright, now let's talk about what's being played. I said before, but I'll say it again. This is the main melody. And this main melody, this line here, is the main motif. It is the main musical idea that ties this entire tune together. This is very important, what you're hearing. I want you to listen again, and I want you to remember what you're hearing. This melodic line is very important. It will reappear throughout this tune in various shapes and forms and permutations. And besides that, it serves as thematic material. There are variations on it, and variations on its rhythms, and it's twisted and transformed in so many different ways. And it really gives this tune, it's really the meat and potatoes of this tune. It's the core of this tune. It's the main musical idea that ties everything together. So remember it well. It'll be very important later on. Got some really cool chords on this square pad in the background. The low pass filter is coming up, so you hear more of those high frequencies. In a second, a lot of numbers and symbols. There's already a lot of numbers and symbols. In a second, a lot more numbers and symbols and random weird crap is going to show up on the screen, and you're going to be like, what the fuck is going on? I'm so confused. Don't worry. I'm gonna break it down for you. I'm gonna explain it all to you. 3, 2, 1. Here we go. We will begin breaking down the various parts of this music video by first talking about the two equations in the bottom left. On the top we've got A equals 450 per second, and on the bottom we've got quarter note equals minute divided by 180. Let's start by breaking down the thing we see up at the top equation. A equals 450 per second. I'll give you the answer right away. This is telling you what we're tuned to. tn-shi is telling you, by using this equation, tn-shi is telling you that A is tuned to 450 hertz. And to break that down further, we're going to need to talk about waves and the fundamental nature of sound. Let's start at the bottom of the keyboard. Let me get my volume back up. That note is A0. It's the A at the bottom of a piano, of a standard piano with 88 keys. A1, that's the next A up. A2, that's the next A up. A3, A4. If this were an actual grand piano, when I hit this key would set into motion a hammer, and this hammer would strike a string, and that string would start wiggling back and forth really quickly at a frequency of about 440 times a second. Think back to physics class, you remember that unit for frequency, hertz, Hz, that means per second. So if I clap twice per second, I'm clapping at a frequency of 2 hertz. Hertz is per second, alright? When I hit that A4, that string, that piano string, is wiggling back and forth at a frequency of 440 hertz. Well, that string wiggles the air around it at the same frequency, 440 times a second. And that wiggly air hits your eardrum and wiggles your eardrum at a frequency of 440 times a second. And then your brain is like, Yo, my eardrum is wiggling back and forth at 440 hertz. I know what that means. That means I'm listening to an A4. That's all sound is. Sound is just wiggly air, and your brain is really good at interpreting wiggly air from your environment as sound. And if that air is wiggling at a constant frequency, say 440 hertz, then you hear a pitch. That sound has a pitch, a constant pitch. Our brains have been doing this ever since our species came about on this planet. Our brains have always been really good at hearing and interpreting wiggly air as sound. It's an ability that is part of what makes us human. Okay, so now we know that the pitch we hear when air wiggles at 440 hertz is A4. That is the A above middle C. This is middle C, the C in the middle of the keyboard. The A above that, ow, my finger. The A above that is A4. So I know what you're thinking. Ray, dude, what the fuck? Why does it say 450 hertz here then, instead of 440? I'll explain, don't worry. When we're in standard concert tuning, concert pitch, A4 is tuned to 440 hertz. So when you go to a symphony, you listen to an orchestra, or you listen to like 99% of music out there, A4 vibrates the air at 440 hertz. Most of the music you're hearing uses concert tuning. But here, in this tune, tn-shi decided to tune their A4 to 450 hertz. Totally up to them. And it's totally up to you whenever you're making music and whenever you're tuning your instrument to tune yourself to whatever you want. When you're tuning your violin, you can tune your strings however the hell you want. When I get a piano technician to tune my piano, I can tell him to tune my A4 to 432 hertz or 460 hertz or whatever. It's just that we've all agreed, for the sake of consistency, to tune our A4s to 440 hertz. All across the board. All the orchestras, most musicians in most genres tune their A4s to 440 hertz. When you hear vibrations faster than 440 hertz, you hear pitches that are higher than A4. For example, this note here, A5. When I play an A5, the air is vibrating at 880 hertz. When you hear wiggly air at a frequency lower than 440 hertz, you're going to hear a pitch lower than this A4. So, like this one, A3. When I play this A3, you're hearing air that's vibrating at 220 hertz. Higher frequency, higher pitch. Lower frequency, lower pitch. And you might notice here that 450 is higher than 440. So we'll say that tn-shi is tuned a little bit sharp, a little bit up, a little higher than what we're used to, from 440 to 450. We tend to associate higher tunings, sharper tunings, with a feeling of upbeatness, a feeling of liveliness. We tend to feel like there's more energy there. And we tend to associate flatter tunings or lower tunings, tunings where A4 is lower than 440 hertz, with an attitude of chilled outness, of laid backness, of being relaxed. So, tn-shi tuned themselves to 450 hertz, tuned their A4 to 450 hertz, in order to, as I would guess, imbue their song with a feeling of upbeatness, to make their song more energetic. Okay, so that's what's going on here in this top equation. A equals 450 per second. Okay, simple enough. How about the bottom equation? Quarter note equals m divided by 180. What the hell could that mean? Huh? What's that all about? Well, I'll explain it to you, and I'll bring back the whiteboard. Turns out I didn't actually need the whiteboard for the first equation, but I sure as hell will need it for this one, because we're going to be doing some math, some algebra. Let me get a sip. Jesus, that hurts. Okay, here we go. Let's write this equation out. Quarter note equals m divided by 180. So I'll give you the answer straight up, and then we'll work towards getting there, alright? This equation is tn-shi's mathematical numerical way of telling you that the song is running at 180 beats per minute. That's it. The song is running at 180 BPM. So why the weird equation? Well, my guess is, in keeping with the aesthetic offered by the rest of this music video and visualizer, equations, math, numbers, computers, EDM, technological stuff. So now let's work back to 180 BPM. We have some assumptions we can make right off the bat. The first one is that M here means minute. Just trust me on this one, alright? The second one is that our time signature is 4/4. And all I mean by that is that a quarter note is the fundamental unit of beat, of counting beats. When we want to count the beats of the song, 1, 2, 3, 4. Each of those, 1, 2, 3, 4, is a quarter note. A quarter note is one beat. Alright, that's the second assumption. Now let's do some algebra. We've got our quarter note equals minute divided by 180. I hope you remember your algebraic rules. If you do something to both sides of an equation, it's like nothing ever happened. The equality still holds. So let me multiply by 180 on both sides. And we get 180 quarter notes equals minute. Now remember my second assumption. I told you that a quarter note was a beat because we were in 4/4 time. How do I know we're in 4/4 time, by the way? Well, every EDM song in the history of EDM ever has been in 4/4 time. This is just something I know because I've listened to a lot of EDM and I'm a musician. All EDM songs are in 4/4 ever. I don't make the rules. That's just how the world works, alright? So we just know this. We know that a quarter note is one beat, which means I can rewrite this as 180 beats, because a quarter note is a beat. And now we've got minute. What I want to do is get all my units, all my terms over to one side. This will allow us to summarize everything in just one expression. I'm trying to get everything over to one side. So now I'm going to divide this side by minutes so I can get my units all on one side. And now we've got 1 on this side, the unitless dimensionless quantity, which indicates that everything on the other side divides out. Alright? We've got 1 equals, oh hey, what do you know? 180 beats per minute. That's what we wanted to arrive at, 180 beats per minute, BPM. Give yourself a pat on the back. We did it. We proved that this equation was just a mathematical, numerical way for tn-shi to tell us that this song was running at 180 beats per minute. So they just took the figure of 180 beats per minute and they threw it on one side of an equation and they rearranged stuff in order to arrive at quarter note equals m divided by 180. That's what you see in the bottom left corner of this video. Alright, glad you came along on this mathematical journey with me. Alright, that does it for the bottom left corner. That's what these two equations mean. The top equation is telling you about the tuning, and the bottom equation is telling you about the beats per minute, about the speed that the song is running at. Let's move on to... God, I need a cough drop. Let's move on to the top left. This one is going to be confusing because the top left is a real clusterfuck. There's a bunch of numbers flying around and they're appearing and disappearing really fast. And there's 4s and there's 3s and there's 2s. Yeah, this will take a while to explain. As I did with the last section, I'll give you the answer as to what this is straight away, and then we can work towards figuring it out in more depth together later, alright? So here's what this is. What you're seeing in the top left is a numerical and positional representation of the polyrhythmic pattern that drives this tune forward. Alright? That was a word salad. Let me repeat it. What you're seeing in the top left corner is a numerical and positional representation of the polyrhythmic pattern that drives this tune forward. Okay, now let me explain what that means. As we talk about what's going on here in the top left, I'm going to briefly touch on two related topics, and those are reading and writing and counting rhythms, and polyrhythms. And those are going to come into play as we go through this whole mess of what's going on in the top left. Alright? First, let's talk about the top line. The line with the fours in it. We've got 4 fours in it. You might notice, as you watch the video, and as you're counting along with the song, that the top line appears and disappears completely every time 4 beats pass in the song. 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. I can't snap fast because I'm tired and my muscles are aching because I have COVID-19. I can't snap fast. I'll just tap my pen on my hand. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Notice that? The top line completely appears and disappears whenever 4 beats pass in the song. So you could call that top line a complete measure. A measure made of 4 beats. Remember, we're in 4/4 time. And 4/4 time indicates 2 things. One of them, we talked about earlier, was that a quarter note is the fundamental unit of counting. That quarter note was 1 beat. But the second thing that a 4/4 time signature indicates is that there are 4 beats, 4 quarter notes per measure. That's exactly what we're seeing here. 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Every time we count 4 beats, that top line appears and disappears. It fills up, and it disappears and then comes back. So it's almost like one full line is a measure, because you can fit 4 quarter notes into it, and 4 quarter notes make up a measure. And you'll also know, if you did the required reading, or if you already know about rhythms and stuff, that a quarter note can be broken down into 4 16th notes. Alright? A quarter note can be broken down into 4 16th notes. And thus we posit that every number here represents a group of notes. And the value of the number represents how many 16th notes long that group is. Right? Because each of these 4s represents a quarter note, and there are 4 16th notes in a quarter note. This makes perfect sense to me. Now let's draw this out. 16th rest. Can I fit this all into the bar? Yes, I can. Awesome. Okay, and it's the same for the second bar. 16th note, 16th rest, 16th rest, 16th rest. This is our first group of notes. Notice how it is equivalent. It is the same length as 4 16th notes, aka 1 quarter note. These are 16th note rests. I'm just putting it there because that's how I want to write it. 3, E, and 4, E, and In case you don't know, this is how we like to count 16th notes. When you've got quarter notes, you count 1, 2, 3, 4. When you're breaking them up into 16th notes, you count 1E and a 2E and a 3E and a 4E and a. This plus here is an and. And the E's and the U's you just say as E's and U's. So 1E and a 2E and a 3E and a 4E and a. So we've written out the top line and it all makes sense to us. The top line here has 4 4s. The 4s represent groups of notes. And the value of the number, the 4, represents how many 16th notes long it is. 1, 2, 3, 4 16th notes. And the whole thing vanishes and refreshes every measure, every 4 counts. 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Refresh, 2, 3, 4. Refresh, 2, 3, 4. Refresh, 2, 3, 4. So this makes perfect sense to us. The top line is just a bar of this rhythm. Okay, I've written out 2 bars because it'll become important soon. But now we know what the top line is. It makes perfect sense. How about the bottom line? Huh? What the hell is going on down there? We've got 3s and we've got 2s and we don't know what the hell is going on. And we're like, what the fuck, dude? I did not sign up for this. Let me break it down for you. Here we go. If we follow the same logic we used to write out this top line in standard rhythmic notation, follow that same logic with the bottom line. There's a number there, the number 3, which indicates there's a grouping of notes. And the value of the number, it's 3, in case you can't read. The value of the number indicates how long that grouping is. In this case, it's 3 16th notes long. So we've got a 16th note, 16th rest, 16th rest. Taken together, this group is 3 16th notes long. Okay? Then we've got another one. Boom, boom, boom. And we've got another one. It's a bunch of 3s all the way down. Okay, so far so good. How many 3s are there? 1, 2, 3, 4, 5, 6. That means we should put 6 groupings that are 3 16th notes long in here. So there's 1 grouping. Cool. 2 groupings. Cool. 3 groupings. Cool. 4 groupings. Cool. 5 groupings. Cool. We want to fit another grouping in here, but there's something wrong. Can you tell me what's wrong? Can you tell me why we can't fit this grouping in here? Ding, 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 ding. You got it. It's because each measure is only supposed to have 4 quarter notes in it. 1 quarter note is 4 16th notes. So there should only be 4 16th notes in a measure. I meant to say 16, so please disregard that. Thank you. Let's count the 16th notes, or the 16th note equivalents, because these are rests. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. If we were to fit that 6th group of 3 in here. But we can't do that, because each measure is only supposed to have 16 16th notes in it. So what are we to do? The answer is simple, really. Borrow from the next measure. There's our grouping. 1, 2, 3. Okay? Now we can continue writing this rhythm out according to what the next bar looks like. Because we've already established that one line represents 1 bar, which is 1 measure. So let's move on to the next one and write down what we see. Okay, we see a 3 3 3 3 2. Let's write that down. And 2. And that should be good, right? We have a 3 3 3 3 2. We have a 3 3 3 3 and a 2. Okay? Everything's great. But we need to make sure that everything's great. Let's count the beats. Let's count the number of 16th notes and make sure we didn't break any rules. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Cool. So this bar is good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Cool. 32 16th notes in total across these 2 bars. 16 in this one, 16 in this one. And we're starting to notice something, that there's some space right here before this 3. Kind of like the rests that were here before this note. Kind of peculiar how those match up, right? And you also start to notice, as you play this back, that the bottom line repeats itself perfectly every 2 measures that pass. So there's this one, and then we've got the space, and then this one again without the space, and this one with the space, and this one, and then this one with the space. See how every 2 measures the whole group repeats. 2 3 4 1 2 3 4 2 2 3 4. Repeat 2 3 4 2 2 3 4. Repeat 2 3 4 2 2 3 4. Notice that? It's all coming together. It's all coming together. Everything is coming together. That is exactly what we've written here. What's going on up there matches what's going on down here exactly. All I've done is written what's happening here, written these numbers out as a rhythm in standard notation. That one repeats every 2 measures. This rhythmic pattern repeats every 2 measures. That rhythmic pattern is made up of a bunch of groups of 3 16th notes, and then 2 16th notes at the very end. Come on. There. And then a 2 at the very end. 3 3 3 3 3 3 3 3 3 3 2. And it all fits 16 16th notes, 16 16th notes, 32 in total. Add up the numbers here. Add up the numbers. Wait, show me the last 3. Add up the numbers here. 3, 6, 9, 12, 15, 18. And then 18, 21, 24, 27, 30, 32. Mind blown. 32 16th notes. The numbers here add up to 32. Oh shit. And there it is. Hopefully I've explained it to your satisfaction. Let me say it one more time, the thing I said at the beginning. What's going on up here in the top left corner is nothing more than a numerical positional representation of the polyrhythmic pattern that drives this tune forward. When I say positional, I mean the position of this number tells you where the note is placed in relation to the other notes. And when I say numerical, I mean the value of this number tells you how long this grouping is. That's all it is. Okay, now let's talk about polyrhythms and what it means for something to be a polyrhythm. And I have to exit out of here and then head to Wikipedia, where I've already pulled this up conveniently. Here we go. From Wikipedia, a polyrhythm is the simultaneous use of two or more rhythms that are not readily perceived as deriving from one another, or as simple manifestations of the same meter. So what the fuck does that mean? Let me count this out for you, and you'll see exactly what I mean. Beer and a cough drop. What a crazy combo. Anyway, so these two lines were running in concert with one another as we were watching this song, as we were watching this music video go along. See, the top and the bottom running in synchrony. And we know that the top line represents this rhythm, and that the bottom line represents this rhythm. Now let me actually count these rhythms out for you, so you can hear what they sound like played together. And you'll start to get what the fuck all this polyrhythm business is about, okay? With my left hand, I'm going to snap the top line. It's just 1, 2, 3, 4, 1, 2, 3, 4. I'm waiting 4 16th notes, or 1/4 note, in between each snap. 1, 2, 3, 4. Simple enough. And on the bottom line, I'm going to be snapping this pattern. Before I snap them together, let me count the bottom line on its own so you know what it sounds like. I'm going to be snapping the quarter notes. So 1, 2, 3, 4. But I'm going to be saying with my words, emphasizing the count that every note is on. So that would be 1, and E, 4, etc. Alright? I'll do it really slowly at first, and then I'll speed it up gradually. Okay, here we go. 1, 2, 3, 4. 1 E and a 2 E and a 3 E and a 4 E and a 1 E and a 2 E and a 3 E and a 4 E and a... Okay, now I'm going to snap with my right hand the same pattern that I was saying. I'm going to snap every 3 16th notes. And in my left hand, I'm going to do what I said I was going to do before. I'm going to snap every 4 16th notes. Okay? Let's start slow. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, now I'm going to go faster, but I can't snap any faster because I'm really bad at snapping. I'm going to tap it out on the piano. 1, 2, 3, 4. I'm going to repeat them. All right, here we go. 1, 2, 3, 4. Now you hear these two rhythms clashing with one another. This is what makes a polyrhythm, that feeling of unease, of rhythmic tension, of being unsure where you are in the rhythm, and then when it all repeats, when it all comes back together, you feeling like you're back on solid ground. And this polyrhythm here happens to be known as a 4/3 polyrhythm. And that's because in the span of time, my right hand is snapping 4 beats, snapping 4 counts. 1, 2, 3, 4. My left hand is snapping 3 counts. On my right hand, 1, 2, 3, 4. 1, 2, 3, 4. And on my left hand, 1, 2, 3, 1, 2, 3. That's why this is called a 4/3 polyrhythm. We've got the 4 and the 3. 4/3. Now let's listen to why this is important to this tune. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 1. You can hear the quarter notes, the underlying beat. 2, 3, 4, 1, 2, 3, 4. But now pay attention to the voice that is carrying this bottom line, the one with the 3s and 2s in it. Okay, I'll sort of count it out with my voice so you can hear it more easily. Do you hear that? Do you hear which voice, which instrument, which melodic line is playing the rhythm that we wrote out here? That was mapped out by this bottom line. Do you hear that? It's the main melody of the tune. That's why I sat here using my whiteboard, why I sat here at my keyboard drawing these rhythms out. Because this rhythm was important. It was very important. Because it's the main melody of the tune that's playing this rhythm. Alright? So, to wrap things up, the top line is just quarter notes. It's the count, counting the beat of the song. 1, 2, 3, 4. 1, 2, 3, 4. And the bottom line here forms a polyrhythm when played with the top line, a 4/3 polyrhythm. And the voice that's carrying the rhythm, indicated by this bottom line, is the main melody, the main motif, the main musical idea of the tune. Okay, that took forever. Glad we're done with that. Now let's talk about what's going on in the middle of the screen in this section. 2, 1, 0. Let's talk about what's going on right there. So this new section hits, and you see some numbers and symbols appearing in the center of the screen on every kick drum hit. The kick drum is that low drum that you're hearing right there. Also called the bass drum, because, you know, when you hit it, it resounds in the bass frequencies. So you're seeing a bunch of numbers and symbols appearing in the middle and wondering what those mean. The numbers are scale degrees. We're in the key of F minor. At least we're starting in the key of F minor. F minor is a great key. It's the key of Monin, Art Blakey, Bobby Timmons. Getting carried away. It's also the key of Golden Time Lover. One of my favorite openings from Full Metal Alchemist Brotherhood. But then again, all of the openings from that show are fucking amazing. Okay, where was I? F minor. God, I really need some sleep. So let's count these scale degrees that are appearing in the middle of the screen here. So hold on, let me play F minor for you. It's got 2, 4 flats. These flats. B flat, E flat, A flat, and D flat make up F minor. But even though we're in the key of F minor, when we're counting up scale degrees, we're going to count using the major scale. That would be F major. Alright? I don't know who made this rule. I don't know why this rule is the way it is. There's probably some good reason. I don't know. But we're counting scale degrees, so let's count up the major scale. So we see a 6 there. Let's count up. 1, 2, 3, 4, 5, 6. We found our 6. It's D in the key of F. But we see a flat there, which means we need to flatten it, or go down 1/2 step. There's our flat 6. Okay, so we've got the note indicated by that scale degree and symbol. Then we've got 4. Where's the 4? Let's count it up. 1, 2, 3, 4. There's 4. B flat. Our flat 6 was D flat, and our 4 is B flat. Let's keep going. Oh, we see another one. Flat 2. Let's count up. 1, 2. And we gotta flatten that, so we get G flat. So now we have flat 6, 4, and flat 2. I wonder where this could lead. I wonder what we're going to get from all this. We've got 1. That's F. Very cool. And we've got 6. We already know what this one was. We counted up before. 6. That's D. Then we've got 2 and 5. What's 2? It's this one. And what's 5? 1, 2, 3, 4, 5. It's this one. C. So now let's put all those together. Starting from flat 6, we've got flat 6, 4, flat 2, 1, and then 6, and then 2, 5, and back to flat 6. I wonder what this could be. Well, I'll tell you. It's the bass line. It's the bass line that you're hearing. I'll play it in time with the song now. Of course, it sounds a little different because I am not tuned to 450 hertz like this song is. But you get the image. You get the picture. Let's keep going. There's more stuff here. There's a 5, 4. We've got a 7 to a sharp 4 to a flat 2. 7. Let's count up to that. 1, 2, 3, 5, 6, 7. Here's our 7. And we've got a sharp 4. Let's count up to that. 1, 2, 3, 4. Here's our 4. We got to sharpen that, so we go up a half step. We get to B. And we've got a flat 2. We already know what that is. G flat. And then we have a 5 next. There. 5. C. Okay. And then, what's next? 6. A D flat. Okay, let's play this pattern here. And then we've got some cool harmonies going on here. 2. Sharp 4. 2. 5. 2. 5 again. 5. And by the way, the bass line implies the chords, and the chords are the harmony. The chords make up the harmony. So this stuff that's going on in the middle is pretty much a blueprint for the harmony of this part of the tune. Okay, now let's move on. Oh, what's that? You hear that in the background? I know what that is. I'm hoping you know what that is too. Let me erase all this first so I can set up something that's very important to me, and that is the motif counter. So we heard the motif being introduced once at the beginning. And we're hearing it again now. So that makes 2. There it is. Also, I just want to point out something else cool. During this section, there's a synth patch I love going in the background. That home resonance synth. That sort of synth you hear going like wah 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 wah. There in the background on the 8th notes. I associate that voice, that the way that synth sounds with Resonance by Home, a really popular, I don't know what genre of music it is, it's some kind of electronic shit. A really popular tune, you've probably heard it before. But I love the way that synth sounds, and I'm hearing that here. Yo, I'm dropping in for an editor's note. I'm going to be doing a few of these throughout the video. The first editor's note is about the meanings of each of these chapters' names. The chapters of the tune, they each have their own names. Like this one, Genesis, this one, Impetus, Acceleration, Recursion, etc. I'm going to be breaking down what all the chapters' names mean, because they do have meaning. Okay, the first one, Genesis. Genesis meaning the start of something. And this is the start of the tune. Yeah, that makes sense. Then we have impetus. Impetus being the driving force, or the push behind something. And this section does push us forward. It drives us forward to the build-up, which leads to the first drop. And this section can be thought of as a driving force because in this section, the polyrhythm, where is it? Let me show it. The polyrhythm that makes the bulk of this tune's rhythmic interest is really pounded into our heads. I mean, the polyrhythm was present in the early section, but it was quieter. It didn't take the forefront. Now in this section, with the kicking, powerful drums carrying this polyrhythm, that polyrhythm really starts to take hold in our heads. And then we have the next section, acceleration. This section is called acceleration because we're moving forward to the first drop. This section is called recursion, and I'm not going to be the guy to pretend that I can figure out the meaning behind everything. So I don't have a fucking clue why this section's called recursion, but sometimes I'll just assume that tn-shi picked a word because it sounded cool, and that's what I'm gonna do here. But maybe if we dig a little deeper, you know, recursion is a process in programming, computer programming, in which a function calls itself in order to solve a problem. You know, one could look at this and think that the way these rhythmic equations unfold looks kind of recursive. The way that these rhythmic equations are generated. Because everything is unfolding note by note. I'm reaching. The next section, oracle. Oracle referring to a foretelling of the future. And I guess this section is called oracle because, well, if you listen to it, we're playing the motif on a very hype-sounding saw synth. And this section sounds a lot like Dimension, except Dimension is in a different key. It's the same motif being played on a very hype synth. So I'd say Oracle is named Oracle because it's a foretelling of a future section. It's a foretelling of Dimension. And then we have metacognition, which I think tn-shi named because it's a cool word. I don't know why the fuck this section is called metacognition. But metacognition means meta, above or beyond, and cognition, thought processes. Metacognition means going beyond your own thought processes, or being cognitively aware of your own cognition, of your own thought processes. I think tn-shi picked it because it's a cool word. Nothing more to say about that. Then irrationality, the jazz piano shit. I think tn-shi called this one irrationality because irrationality of or related to the state of being irrational. Like maybe an irrational number, or being irrational as in being without logic or without reason. Maybe this section is called irrationality because no rational, sane person would come up with these harmonies. I don't mean that. And then the next section, transcendence. Transcendence. In this section, there are a bunch of key changes. Yeah, we've got a whole bunch of key changes. So you can think of this section as us transcending the previous key we were in. We're going beyond. We started this section in some key. What did we start it in? Show me. D minor. We started in D minor, and we end up moving beyond that through a series of modulations until we end up in G minor. We go through a whole bunch of modulations and then we end up in G minor. So we are transcending our previous key. Then dimension. This is my favorite fucking part of the tune. If I didn't already mention that, I'm mentioning it now, and I'm going to mention it again later on in the video. So yeah, this is the best part of the tune. And I don't know why the fuck it's called dimension. Ask tn-shi. Alright. Then diffraction. This is also probably a chapter title that tn-shi picked because it's a cool word. Don't fucking ask me, I don't know. But if I were to reach a little bit, just humor me. If I were to reach a little bit, the lead synth in this part that carries the melody and cuts through everything else and comes out on top can be thought of, by me at least, I think of it like a beam of light. Because it just pierces through everything, cuts through everything. And diffraction is a phenomenon of waves, like light waves, in which they pass through a small opening and they split. So, you know, that synth being like a light beam, diffraction being a phenomenon that occurs when beams of light or other waves pass through a small opening and split. I'm reaching here, but it's fun to reach. And chroma. Chroma, meaning color, referring to color. This section is very colorful. It's very rich. There's a lot going on. There's a lot of bass growls, bass wobbles, a lot of sound effects, a lot of filter sweeping. This section is very rich, very colorful, very lush, and very complex. There's a lot going on. And then terminus, meaning the end of something. Yeah, that makes sense. This is the end of the song. Okay, that's it for this editor's note on the names of these sections. Big build up. Boom. Okay, now this section. Shit's going crazy. But if you do a little math, you should be able to figure out what's going on. Okay, it's another equation. tn-shi really does love their equations. So we've got 4 quarter notes on the left side. Let's try adding up everything on the right side and seeing what we get. Go 1/4 plus 1/4 plus 1/2. That's 1. Plus 1/4 plus 1/4, 1/4, 1/4. That's 2. 1 fourth, 1 fourth, 1 fourth, 1 fourth. That's 3. 1 fourth, 1 fourth, 1 fourth, 1 fourth. That's 4. Okay, so we've got 4 on the right side and 4 quarter notes on the left side. That tells us all that we need to know. It tells us that these fractions here are fractions of quarter notes, because we added up all the fractions and we got 4, and on the left side we've got 4 quarter notes. So if we're seeing 1 fourth, we're hearing a 16th note. If we're seeing 1 half, we're getting an 8th note. Pretty simple. So what exactly is the rhythm being indicated by all these numbers? Well, it's whatever rhythm is being emphasized at the moment. It could be the rhythm in the synth, could be the rhythm in the drums, could be the rhythm in the wobble bass, as it often is. For example, there it was a rhythm in that plucky growl effect. You heard it going really quickly. I'll point it out again when we get there. There, that really quick, plucky, glitchy electronic sound effect. And there you heard it going 16th notes with the synth. Here. There. So it's just whatever rhythm is being emphasized, whatever rhythm is at the forefront of the tune at the moment, that is what's being indicated by these numbers here. Oh, by the way, that 1/8 there, those are 32nd notes, which are worth half of a 16th note. They look like this. Boom. A 16th note looks like this. A 32nd note looks like that. What were the 1/6? Yeah, there we go. You'll also see these, the 1/6, and you'll think, what's 1/6 of a quarter note? And be kind of perplexed. Because it was easy to cut a quarter note in half. You get an 8th note. And into quarters, into fourths, you'll get a 16th note. But what's 1/6 of a quarter note? Well, we can rewrite 1/6 as 1/3 times 1/2. And we know what we get when we cut a quarter note into thirds. We get 8th note triplets. You all know what a triplet is. You know, if I'm counting quarter notes like this, 1, 2, 3, 4. I can break it into 3 equal pieces and count them like this. Count those pieces like this. 1 and 2 and 3 and 4 and 1 and 2 and 3 and 4 and you get these 8th note triplets by splitting a quarter note into 3 equally sized pieces. And you've heard triplets before. You've heard the triplet flow. You've heard modern hip hop. It's everywhere.
If I take another one down, I'm gonna drown in some poison, abusing my limit. I think that I'm feeling the vibe. I see the
So that's the 1/3 part taken care of. But how about the 1/2? We've got to cut each of these into halves. How do you cut an 8th note triplet into a half? You get a 16th note triplet. That's what you do. 5, 6. If I were to count quarter notes by snapping, I would count sextuplets, or 1/6 of a quarter note, by tapping on my right hand. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's what sextuplets sound like when you take 1/6 of a quarter note. Sextuplets. Here's also something we should touch on. Why the hell this says 3.5 quarter notes? Like, what's going on? I thought a measure was 4 quarter notes long, and suddenly you're throwing a 3.5 at me. All the other ones said 4, so what's going on here? I will explain. I completely botched the explanation for this part, so I'm redoing it. I'm reshooting and re-recording everything. I'm still sick, by the way. 3.5 quarter notes, and then 4.5 quarter notes. Like, what's the meaning of that? Well, we can start out by adding up everything on the right side over there, and just making sure that it actually is 3.5 quarter notes. So we add 1/2 to 1/2. That is 1, then 1/4, then 1/4. That is 3, and then plus 1/2. So that makes 3.5 quarter notes. So we know that at least the equation holds, but we're still wondering why it's not 4 quarter notes, because all the other ones have been 4 quarter notes. So then let's add up what we see here on this next part where it says 4.5. So we've got 2, and then we've got 3/4 and 1/4. That added up is 1. So we have 2 plus 1, that's 3. That makes 1. So all that together is 4. And then we have 1/8 plus 1/8 plus 1/4. Add that to what we already have, and we get 4.5. So this equation holds true too. So at least we know that nothing is fucked up with the math. But now we just want to know why it's written like this. Why the first part was written like 3.5 and the second part is written like 4.5. Now let's write out this rhythm in the way that I did earlier, where I just look at the fractions and I write out what I'm seeing. So we've got 2 bars, and we start out with 1/2, that's an 1/8 note, 2 1/8 notes. So we've got then 1/4, which is a 16th note, plus 3/4. 3/4, that is equivalent, that's the same length as an 1/8 note and a 16th note. Because 3/4 is 1/2 plus 1/4. And we know 1/2 is an 1/8 note, and 1/4 is a 16th note. I'm going to write it like this. Whenever you see a dotted note, just know that this means something that is equivalent in length to the note value you see plus half of that. So if, for example, I had a dotted quarter note, you would know that the length of this thing here was the same as length of a quarter note plus length of an 1/8 note. And if I had a dotted, let's do a dotted half note. If I had a dotted half note, you'd know that this was the same length as a half note and a quarter note. So we're just taking this thing and then adding half of this to it. 1/2 is an 1/8 note. We knew that. 1/4, 1/4, 2 16th notes, and then 1/2, which is an 1/8 note. So I can write it like this: the 2 16th notes in the middle, and this one here, the 1/2. And this does it for our 3.5 group. But we know that each measure is supposed to contain 4 quarter notes, and there's only 3.5 here. Well, let's not let that bother us for now, and let's just keep transcribing this rhythm. Let's move on and summarize what we see on this next segment of the video here. Let's just keep writing and see where we go. We see a 2 divided by 1, that means 2 quarter notes. We know that 2 quarter notes are the same length as a half note. And now we are done writing out this strange rhythm. And we know that everything from the half note onwards is 4.5 quarter notes long. Now we can answer the question of why the first segment of the video was written as an equation where the left side had 3.5 quarter notes on it, and why this part of the video is written as an equation with 4.5 quarter notes on the left side. The answer is because these aren't supposed to align with measures. They're not. We know that measures are supposed to have 4 quarter notes in them. These don't. So these have nothing to do with measures. Alright? The measure bar line falls somewhere else. So we know that if we were to divide these into 2 measures, 2 bars, each containing 4 quarter notes, it would have to fall somewhere outside of here and in here. So like somewhere around here. So let's work on that. Let's try doing that. In order to do that, I'm going to need to, unfortunately, redraw all of this. Damn, I'm just making more work for myself. Now let's figure out where to put the bar line. And to do that, I'm going to complete this measure. Every measure has 4 quarter notes in it, so let's count. 1/8 note, that's a quarter note. 16th note and dotted 1/8 note, that's a quarter note. 1/8 note, 2 16ths, same length as a quarter note, and then an 1/8 note. In order to complete this measure, we need one more 1/8 note. So I'm going to add that one more 1/8 note right here. Boom. We have completed this measure. Very good. Now let's complete this measure. We know that this group started with a half note, and we know that the half note began as part of this bar, as part of this measure. So in order to complete the half note equivalent length, we need to add something to this eighth note's length in order to get something that's 2 quarter notes long. What could we add? We add a dotted quarter note, because a dotted quarter note is equivalent in length to a quarter note and an eighth note. So here's our half note. And now I'm introducing something very important to understanding all this. This little smiley squiggle is a tie. In order to play 2 notes that are tied together, you play the first note and you just hold it, you don't let go until the second note's length is complete. You don't play this note and then let go and then play the next one. When there's a tie, you hold it down until the second one is complete. Alright? Okay, then we have 3/4. And we are done writing. Now we've made sense of it all. The reason the first segment of the video showed 3.5 quarter notes was because it was describing this group of notes. This group of notes here. It had nothing to do with measures. It had nothing to do with where the bar line falls. And the reason this one, this segment of the video shows 4.5 quarter notes is because it's describing this group of notes. Also has nothing to do with where the bar line falls. The rhythm makes sense. The rhythm is like any other rhythm. It's just that the bar line falls here. This really is just like any other old rhythm you know. It's just different because part of this measure spills over into this measure. It's tied. So what we're doing is we're playing over the bar line. So far you've been familiar with rhythms that neatly wrap themselves up every bar. Like 1, 2, 3, 4. 1, 2, 3, 4. That rhythm is just quarter notes. There are 4 quarter notes in a bar. Nothing is spilling over from one bar to the next. But if we do 1, 2, 3, 4, 2, 3, 4, that would be 3 quarter notes and a half note. And that half note would spill over from one bar to the next. And that half note would be written like this, spilling over the bar line. If we were to write out the rhythm that I was counting, it would be, let me count it again. 1, 2, 3, 4, 2, 3, 4. Notice, we're not playing this as its own note. We're playing this as part of a group that started in the past measure. That's pretty much what's happening here, although the subdivisions of notes are smaller and it's all happening faster. Now, listen back to the song and tell me that you hear it. Tell me that you hear a beat happening in this measure and spilling over into the next one. Did you hear it? Get ready. That very last hit of this bar here was held over the bar line. I'll point it out when it happens again. There. And one more time. There. Yo, I'm back for another editor's note, and this time I'd like to introduce you to a guideline that musicians like to follow when they're transcribing rhythms. Here you'll see the rhythm that was in that 3.5, 4.5 beat part of the video that I drew on the whiteboard, except it's written a little differently, especially over here in the second bar. The guideline that musicians like to follow is making it very clear where the beat lies when you're transcribing a rhythm. When musicians are writing transcriptions for rhythms, we like to make it very clear where the beat lies because that makes it easy to look back at the rhythm, take one quick glance at the transcription, and immediately know how to play it. Because once you know where the underlying pulse is, you can frame everything else around that, and you can figure out where the other beats are in relation to the underlying pulse. If we try that for this rhythm here, we see we're in 4/4, which means that there are 4 quarter notes in a measure. So we need to fit 4 counts worth of quarter notes into this measure. And we can do that really quickly. We see that this is 2 eighth notes, so we know that beat 1 is here, because we're starting on beat 1. We see that this is 2 eighth notes, so we can move on and put beat 2 here. We see that this is worth a quarter note, so we can put beat 3 here. And we see that this is worth a quarter note, so we can put beat 4 here. Really quick, really easy. We see that we can put beat 1 here, because we start the measures on beat 1. But we know that we don't sound this note, because this note is tied to the last note in the previous measure. So we're just holding down this one and holding it over the bar line and playing this. So we know that beat 1 falls here, but it's not played. It's not sounded. It's still there, though. And we see that this is a dotted quarter note, which means it's worth 1.5 quarter notes. So that means beat 2 falls here and is silent. And we know that this is the and of 2, because this is a dotted quarter note. And we know that this together is worth 2 quarter notes, so we can immediately place beat 3 here. And we see that this is worth 1 quarter note's length, so then we can immediately place beat 4 here, and then we're done. We instantly knew where the beats were, the 1, the 2, the 3, and the 4 were, by reading this transcription. This transcription made it really easy to figure out where the beats lie, because of how the notes are placed and how the beams are connected. So notice here, these 2 notes are together. That indicates a group. And because there's nothing connecting these 2 groups of notes, like no beam here, at a really quick glance, we can tell that this is one distinct group of notes, and this is another. And we can see that it's worth 1 quarter note. Same thing goes here. There's nothing connecting these 2, no beam. So we know that this is a group. Same thing here. We know that this is a quarter note. This is a quarter note. We can see this apply on a much greater scale in measure 2. We can start on beat 1 and then notice that this is a dotted quarter note, and then we see that this is an 8th note. So then we immediately know that together, these 2 are worth 2 quarter notes. And there's a separation here, so we know that beat 3 goes here. And there's a separation here, and we see that this is worth a quarter note, so we know that beat 4 goes here. Based on how the notes were placed, and based on the placement of beams, or the lack of beams in between groups, we could very easily pick out how much each group was worth. We saw that this was a quarter note. We saw that this was a quarter note. We saw that this was a quarter note. And it's all thanks to the placement of the beams, or the lack of the beams. We see each of these groups as distinct groups, and we can very easily tell that they're worth a quarter note long. So then we know where to place the beats. Beat 3 goes there, beat 4 goes there. It's very easy to count. That's why, subjectively, musicians would tell you that this transcription was a better transcription than the transcription of the rhythm that I drew on the whiteboard. This one is better because it's easier to read. And it's easier to read because it makes it very clear where the strong beats, the 1s, the 2s, the 3s, and the 4, lie. And once you know where the 1s, 2s, 3s, and 4s lie, you can build out the rest of the rhythm around those, using these as your anchor points. Using these to guide you. Making it clear where the beat lies makes for better rhythmic transcriptions. Okay, that does it for this re-recording. Let's move on. Oh, what's that? You heard it again. It's the main motif again. Listen to it again. It's glorious. It's lovely. Now might be a good time for me to explain what's going on the left and the right side. On the bottom, it's pretty self-explanatory, I suppose. It's just telling you what notes are being played. Those are your keys, laid out like they would be on a piano. Your C through your B. The other stuff on the left and right might not be so self-explanatory. I guess I should start on the right side. This is the waveform of the song. This is what is literally happening to the air as it wiggles and as it hits your eardrum, and then what you're hearing is this. Let me illustrate that better with an example. Imagine we took that, what you see over here, and we rotated it so that it was on its side, so it looked like this. Shittiest drawing I've ever done, but I'm just trying to illustrate an example here, okay? Imagine we took that and we shifted it on its side and plotted this on an XY axis. On our X-axis, we have time, and on our Y-axis, we have air compression. Air compression, alright? I hope people are able to read that. So, we've plotted this waveform on this graph. Now let's imagine that this graph describes how compressed a certain area of air is. Like, let's say a given cubic centimeter, or whatever, cubic inch, whatever the hell. If a point is up here, it means at this point in time, that cubic centimeter of air is very compressed. If a point is down here, it means at that point in time, that cubic centimeter of air is very loose. Alright, so how tightly packed that air is varies with time. Let's say we've got this cubic centimeter of air here. Alright, so we start here, and then it gets, it's getting loose. It's getting very unpacked, and then time is going on. And then here, it's not that compressed, and it's not that uncompressed. And then it gets up here. Oh, now it's getting super compressed. Time is going on. Now it's getting less compressed. Back to being not very compressed or uncompressed. Time goes on. It's uncompressed. Time goes on. You get the picture. Now imagine that all the stuff that's going on over here on the right, this insane, colorful, flashing, dancing wave, is here. Yeah, that's this. that's totally this. And imagine that is happening to the air. The air is being compressed and decompressed as time goes on, and it's hitting your ear. If air that were compressed and decompressed, according to this graph here, because this is totally what's happening here, yeah. If that air being compressed and decompressed, according to this graph, were to hit your ears, you would hear this. That's what's going on the right side over here. That's the waveform of the tune. It is describing the compression and decompression as time varies of the air that is hitting your eardrum and causing you to hear this tune. Kinda confusing, but kinda cool. Okay, now let's talk about the left side. We've already talked about what we're seeing on the right side of the screen. That is the sound waveform that is hitting your ears and causing you to hear this beautiful tune. But what about the left side? Well, I'll give you the answer straight up, and then I'll explain it in more detail. On the left side is a frequency band visualizer. It shows you the spectrum of the sound waveform on the right. Up at the top would represent low frequencies, at the bottom would represent higher frequencies, and the size of the bar, the width of the bar at a particular location tells you how loud the sound is at that frequency. Okay, now let's get into more detail. The details of the Fourier transform you won't need to worry about because honestly, I don't fucking get it either. But I do know that every single waveform out there, every wave, no matter how complex it is, can be described as a sum of sine waves of varying frequencies and varying amplitudes. And B, that if you take the Fourier transform of a complex sound waveform, like what we've got on the right side of the screen here, if you take the Fourier transform of that, you will end up with all of the constituent sine waves that make it up, with their varying frequencies and their varying amplitudes. So, one more time. All waves, all complex waves, that includes complex sound waves, can be expressed as a sum of simple sine waves. No matter how complex they are, if you have enough simple sine waves and they're in the right frequencies and amplitudes and you sum them together, you can get a complex wave, alright? And using a Fourier transform, we can break a complex sound wave down into all these simpler sine waves that made that up, alright? And it's using this operation, the Fourier transform. That is how we get from the complex sound waveform on the right to the frequency band visualizer on the left. And I've gone and drawn that frequency band visualizer, but I have flipped it so that... Which way did I flip it? I flipped it this way. So that... I flipped it this way. I flipped it so that the top of the frequency band visualizer ends up on the left and that the bottom ends up on the right. And I've thrown it onto an XY axis where X is frequency and Y is how loud the wave is. Alright? So now imagine for all of those sine waves that we've got. We've taken the complex waveform and broken it down into its constituent sine waves. we sort them at a given point in time. We sort them based on their frequency. We put all the low frequency ones over here, and we take all the middle frequency ones and we put them over here. And we take all the high frequency ones and we put them over here. And we take a look at their amplitudes, because at this given point in time, they're all going to have different amplitudes. So now we've got all these waves. We're looking at their amplitudes, and we have all the low ones over here, the low mids over here, the mid highs over here, and the high ones over here. And based on their amplitude, let's draw, I don't know, let's draw a rectangle. If at this given point in time, this sound wave is loud, let's draw a big rectangle. And if the sound wave is quiet, let's draw a small rectangle. If we did that for all of our sorted by frequency waves, we'd get this. This is what we've got. We sorted all our sine waves by frequency, and if the sine wave was a big sine wave, a loud, powerful sine wave, we drew a big bar. And if it were a quiet one, we would draw a small bar. That is exactly what we've got here. That's how a frequency band visualizer works. It takes the Fourier transform of a complex waveform, looks at all the sine waves, it sorts them based on their frequency. The low frequencies go on the left, that's over here, and the high frequencies go on the right, that's over here. So it forms a spectrum from low to high, sorted by frequency. And if at a given point in time the amplitude is big, we draw a big bar, like this one right here. At this particular frequency, this wave is loud, which is why the bar is big. And if the amplitude is small, that means the sound is quiet, so we draw a small bar, like over here. These bars are pretty small. Yeah. That's all there is to it. That's how you get from a complex waveform, like the thing on the right side of the video, to a frequency band visualizer, which is what you're seeing on the left side of the video. It's just that this particular visualizer, tn-shi, flipped 90 degrees. Shit, I flipped it in the wrong direction again. Flipped 90 degrees. So that for this visualizer, the frequency bands, for the low frequencies, they're going to end up on the top, and the higher frequencies are going to end up on the bottom. And as the song plays, as the moment in time I was talking about changes, you can see all the amplitudes changing as we progress forward in time. You can see the spectral frequency band visualizer morphing and changing and shifting as different sine waves at this given point in time at a given frequency have changing amplitudes. You can see it happening right in front of you. Now you know how much of what frequency of thing is being played in the sound waveform. So at this moment in this song, in the sound waveform, we're hearing a lot of bass. Maybe there's a kick drum playing, or maybe there's a synth bass going. And we're hearing a decent amount of mid-range, mid-frequencies. And there's this one band here that's going kind of crazy. Maybe there's a synth, maybe a note played, and the fundamental of the note was right here. And we're hearing not much other stuff up here. Whenever we hear a kick drum, I'll show you an example. Whenever we hear a kick drum, that boom, boom, boom drum, we should be seeing big spikes down here in the bottom. Let's wait. Yep. We hear a kick every boom, 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 boom on every quarter note. And we see big spikes down here. Boom, 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 boom. We see big spikes down here in the low end, telling us that what I'm saying is making sense. All right, that's it. That's all there is to it. Okay, let's erase this. And let's move on. I already added to the motif counter. Yes, I do. Got a modulation here from F minor to D minor. F minor sounded like this. And D minor sounds like this. Some crazy shit is about to go down. Ooh, it's a jazz piano solo. Real shit. Okay, let's talk about this jazz shit. Let's do a very, 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 very brief introduction to jazz harmony and jazz chords. Once again, as luck would have it, I completely messed up the explanation of jazz chords and jazz harmony, and I just completely said the wrong things and labeled the wrong chord tones with the wrong scale degrees and just messed it all up. Maybe the main takeaway for me here is don't make videos when you can barely think straight because you're sick and jet lagged and tired. Oh well, I'll never change. When we think of chords, we always think of triads. These are the chords that have been present all throughout Western European tonal history. Oh my god, what is that shit? Okay, there we go. I wanted the piano. You know what? For this re-recording, why don't we go with something else? Where were we? Chords. When we think of chords, most of the time we think of triads. This is what they teach you in elementary music theory classes. This is a chord. It's a triad. We've got B flat, we've got D, and we've got F. These three tones together make up a B flat major triad. So named because we took the first, third, and the fifth from the B flat major scale. Remember the major scale? 1, 2, 3, 4, 5, 6, 7, 8. We took the first, third, and fifth scale degrees of that scale, and we're playing them together. We've got a triad, a B flat major triad, 3 notes in it. Now, triads are cool. Nobody's saying they're not cool, but to a jazz musician, a triad is a little boring, a little bit bland, maybe. And jazz is anything but boring. So in jazz, instead of using triads as our main building block of harmony, we use 7th chords. All we're doing is taking the 7th scale degree of the B flat major scale, 1, 2, 3, 4, 5, 6, 7, and throwing that 7th on top of our triad. So we've got the first, the third, the fifth, and now the 7th, which in our case is A. There we go. There's our B flat major 7 chord. In jazz, we love our 7th chords, but we can go past that. We don't need to stop counting at 7. If we keep going up, 1, 2, 3, 4, 5, 6, 7, 8, past the octave, and keep counting up the major scale, we get 9, 10, 11, 12, 13. If we just go past the octave a little bit, we end up with ninths. This is a 9th above the B flat that we started out with, a major 9th. And we get 11ths. This is a perfect 11th above the B flat that we started with. And we get 13ths. This is the interval of a 13th, a major 13th above the B flat that we started with. We can make chords using these tones just like we made chords using the 7th. So let's make a B flat major 9 chord. That's what it sounds like. Very pretty. Now let's make a B flat major 11 chord. Kinda cool. Now let's make a B flat major 13 chord. Can you feel the jazz? These chord tones, the 9th, the 11th, and the 13th, are called extensions. And chords that use these extensions are called extended chords. And that's all well and good, but sometimes playing all the chord tones, the 1st, 3rd, 5th, 7th, 9th, 11th, and 13th, can get kinda heavy. I don't always want to play that gigantic, fat, honking chord at somebody. It's kinda heavy. It's huge. It's got a lot of notes in it. So us jazz musicians sometimes omit chord tones. Let's say I want to omit the 5th. The 5th was F. Let's say I want to throw away the F. Let's say I want to omit the 9th and the 11th as well. C and the E flat. So I'm just going to play the G and whatever else I was doing, which was the 1st, 3rd, 7th, and what was this again? The 13th. And we end up with chords with omitted chord tones. And you can mix and match what you want to omit and what you want to keep in order to arrive at the sound you want. You can also take chord tones that were down here, the third, for example, 1, 2, 3, and move them up an octave, like up here. So now I've got first, third moved up here, fifth, seventh, and 13th. G there. Something else we can do with chord tones is alter them. Let's say I'm playing an F dominant 7, and I want to add a flat 9. So we count up to the 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's our 9, and we flatten that, because I wanted a flat 9. Take it down a half step. And now we've got... there's a chord with an altered 9 in there. Very frequently done in jazz. And these alterations can get as crazy or as numerous as you want. You can end up with some crazily dissonant sounding chords. Like this one. Or this one. Okay, now let's build a chord using what we know. Let's say we want to start down here. B flat, the very first note we started with. And let's construct a B flat major 7 chord. There we go. There's the B flat, D, F, A. Let's say we want to add the 9. That's C up here. And let's say we want to move this third, this D, up here. And let's say we want to omit the 5th for whatever reason. So no 5th. Now we've got this. I like the way that sounds. Very calm. Let's say we've got the 11th here. Let's say I want to add the sharpened 11th. So I'm taking this and going up a half step, arriving from E flat to E. Now let's play everything we have together. Got a nice feeling to it. And oh, wouldn't you know, that's the first chord we're seeing in this jazz piano solo. That's exactly what we've got written down there. B flat, A, C, D, E. That's what we've got there. Let's do a similar process for the first chord in measure 2, and then we'll stop there. Okay, so to get here, let's say we want to build an A dominant 7. That's this chord. A, C sharp, E, G. Okay, now let's say we wanted to add the 9. That's B. Okay, let's say we wanted to move the third. That's the C sharp up here. So now we've got... let's say we want to omit the 5th. That's this E. Let's actually say, no, we don't want to omit the 5th. We want to sharpen the 5th. We can do that. So we'll take this E and sharpen it and go up to F. So now we've got this, 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 this. Now let's say we want to take the F and move it up here. So we will do that. So now we've got the A. We've got the flat 7th. I should tell you how we arrived at that. We counted up the A major scale. 1, 2, 3, 4, 5, 6, 7. And we flattened this one. This was a G sharp. Flatten it, now it's a G. So we've got A, the flat 7, G, we've got B, we've got C sharp, and we've got F. And that is our second chord there. It's just that the enharmonic equivalents of some of the notes are written as flats instead of sharps. Because, you know, C flat is the same as B, and the B is written as C flat there. It would be the 9th of this chord. And D flat is the same as C sharp. That would be the 3rd, the major 3rd, up here from A of this chord. So all together again. There's the chord. Okay, if I were to do this for all the other chords in this section of the video, I would be here forever. So let's not do that. Let's save you and I's time, and let's move on with the video. All right? 1, 2, 3, 4. Hear that? Hear that again? The note that's highlighted up in the top above the rest of the notes in these 3-note patterns spells out the main motif. It's everywhere, I'm telling you. It's in every section of this tune. It's important. And then this section, we've got a nice chime or bells or like music box or something in the background. Whenever I hear this melodic movement, I always think Toby Fox. He always writes something that sounds like that in his melodies. For example, Moonsetter. Right there. He loves doing this thing where he jumps up about an octave and then comes down slightly in like the interval of a third or a fourth. So there's that. There's also hopes and dreams. How does that go? No, that's not the part I'm thinking about. I'm thinking about the beginning. Yeah, that part right there. That's very Toby Fox-ish to me. And also one more, like at the end of Umbrella Ultimatum. I'm probably getting the key wrong, but fuck it, who cares? That right there. So now whenever I hear that, it just sounds like Toby Fox. And I'm hearing that in the bells right there. Dun, 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 dun. Right there. That's modulations from D minor to G minor. To B flat minor. And this is curious. F sharp major to B flat major equals G minor. The reason tn-shi is writing this is because B flat major and G minor have the same key signatures. It's the same flats in both. In B flat major, it was B flat and E flat. B flat, C, D, E flat, F, G, A, B flat. And in G minor, it's G, A, B flat, C, D, E flat, F, G. Same key signatures. So the equals there indicates that. Oh, by the way, the best part of the tune is coming up soon. No contest. The whole tune is amazing, but this is the best fucking part of the entire tune. 3, 2, Sometimes there's just nothing to analyze. Sometimes you just gotta let the music take control. Sometimes that's all there is to it. And it goes without saying that this is another addition to the motif counter. You hear it, right? It's the motif. Just played on this super hype-ass square saw synth. Still the same motif. It's everywhere. Just sounds especially beautiful here. Dude, this section is just pure euphoria. Okay. This next section is also especially good. This synth solo. Dude, you know it's not Japanese EDM if there's no synth solo that goes like. Anyway, here, this arrow from F to G indicates that there's a glide. We're not going from F to G like this, or even like this. We're sliding from the bottom note, F, to G. F, up to G. Yep. And this is pretty self-explanatory. Whatever note is on screen is the note that is being played in the monophonic synth that is carrying this solo. Oh, what's that there? Motif counter. Add it. Let's listen to that again. The motif is here. And then we climb to the climax. Check this out here, this very end. If you did the required reading, you would recognize that scale as the G minor pentatonic scale. When that synth is doing that final climb up, it's using notes from the G minor pentatonic scale. Should sound pretty much like that, except way faster. It's going like, and then it comes back down. Some shit like that. Listen to it one more time. G minor pentatonic. And then back down. And then on to the next section. There's legit nothing to analyze here. It's just dubsteppy, glitch hoppy goodness. I'm back for one more editor's note, and this time I'm going to talk about a detail that you might have missed the first time you were listening to Synthesis. I know I sure missed it, but it's a really little detail that actually adds a lot to the tune. Makes it a lot more interesting and gives each section a lot more contrast from one to the other. And that is the snare drum. tn-shi actually switches up what the snare sounds like from section to section. So let's head to recursion, and I want you to just listen to the way the snare sounds here. Well, first off, I'll play what a snare sounds like so you don't get it confused with anything, in case you don't know what a snare is. So that's a snare drum, and the snare drum, the instrument, can be tuned up, can be tuned down, can be made punchy, can be made clicky, short, long, can be muted. You can do all sorts of things with a snare drum. And a synthesized snare sound, like the one tn-shi is using in this EDM tune, can be customized however the hell you want it, because all it is a collection of sound waves. You can make it short, you can make it long, you can pitch it up, you can pitch it down, you can make it really beefy with a lot of low end, you can make it really clicky, snappy, and clappy with a lot of high end or high mids. You can do anything you want to the snare sound. But people who have listened to a lot of EDM, a lot of drum heavy EDM, really associate certain snare sounds, certain ways that a snare could sound, with certain subgenres of EDM. We'll get into that later. Okay, first I want you to listen to the snare used in this section, recursion. Listen closely. It can be kind of hard to hear over the bass drum at times because the two are layered together often. But during this fill, you can very clearly hear the snare. Let me see if I can find it. During that fill, you can very clearly hear the snare. You can hear the snare going da da da. And the snare here in this section in recursion is really short and really clicky. It's like a tuned up breakbeat snare, a pitched up breakbeat snare, or a classic drum and bass snare. Let me play you some tunes that use a similar snare sound so you can hear exactly what I'm talking about. So it's similar to that snare from Unconscious Words, a drum and bass tune, but it's a lot shorter and higher pitched. It's most similar to this one. Yeah, you hear how that snare is really high, really pitched up, and it's really short. Really snappy. It gets your attention. I associate the way this snare sounds with drum and bass and breakbeat. I really love hearing it here. It's just a good snare sound, dude. Okay, now let's move on to Oracle. Listen for the snare here. Notice how the snare here sounds different. It's a lot more clappy, the snare sounds an awful lot like a hand clap, and it might actually be a hand clap layered with some other snare, and the clap is just mainly what we're hearing. The hand clap snare layered combination really reminds me a lot of hip hop beats.
nation. Please don't bomb my nation. And bomb me flew waiting. I got my control when I'm here. You gon' hate me when I'm gone. Ain't no blood pumping.
And samples or drum breaks, instrumental breaks from old soul and funk records.
Move on up and keep on wishing.
Now let's move on to Irrationality, the jazz piano. Here you can very clearly hear the snare. This is actually the same snare, I think. The same snare as we heard earlier in the section Recursion. But it's a lot easier to hear it here. You can hear how short and how snappy it is. It's very short, very fast. It's on and then it's off really quickly. And now for the snare sound used in Chroma. Do you hear how powerful that fucking snare is? Snare just wants to knock you through a wall. This is a classic dubstep snare. A classic dubstep snare with a lot of low end, a lot of power behind it. Very powerful and very punchy. I actually think the kick sounds are also different from section to section. Like if we listen in Chroma, the kick sounds very, very powerful and very punchy, matching the strength of the snare drum. But if we go to one of the drum and bass sections, like in Recursion, this might not be the section I'm looking for. How about Oracle? Yeah, here in Oracle, the kick sound is a lot shorter. There's a lot more high end. It's a lot more stabby and not so much thumpy. And definitely in Irrationality, the kick sound is very different. Yeah, there's a lot of high end to this kick. There's a lot of click to this one. So all this is to say, by switching up the way that the drums sound, the kick and the snare, from section to section, tn-shi gives each of these sections its own character, helps contrast one section from another. And by using kick and snare sounds that harken back to the kick and snare sounds that we might hear in other classic genres of EDM, like the snare in Recursion was very drum and bassy, like a pitched up breakbeat snare. And the snare used in Oracle was very clap-like, reminded me of hip-hop. And the snare used down here in Chroma was a classic dubstep snare, very powerful, very punchy. By harkening back to the drum sounds that we associate with different genres of EDM, Synthesis sort of melds all them together. I just had a crazy realization. That must be why this tune is called Synthesis. It synthesizes all the sounds from all these genres of EDM. Oh my god, my mind is being blown. Holy shit, dude. It is a synthesis, a blend of so many of these genres, and it uses the sounds from all these genres, and it's just... Dude! It feels like this tune synthesizes the sounds and the patterns and the methods of many different genres of electronic music and uses them all in a single tune, which is pretty cool. This visualizer here, the circular waveform, reminds me of those old dubstep videos I used to watch when I was like 12. And that's it. That's the end of this amazing, beautiful, euphoric, confusing, crazy, insane, awesome song. With a kick-ass visualizer and music video to go with it too. Okay, that about does it for this video. I'm out of beer. Almost. Okay, now I'm out of beer. Yeah, that about does it for this video. I have a couple of thoughts to share as a post-video thing. First one, shoutouts to Cooly, my old college roommate. He sent me this video, sent me Synthesis, like, about a week ago? I want to say maybe more than a week ago. I can't even remember. My brain doesn't work because I'm sick. Yeah, he sent me Synthesis not long ago, and I heard it and I was like, holy shit, what a banger. But I also saw the music video, and being a musician, I understood it all instantly because my brain is the size of fucking Canada. But I was like, you know, people watching this music video might not get what's going on, so why don't I try my hand at explaining some of these concepts? Cooly is a major reason this video exists. Shoutouts to him. Another thing, and this will be the last thing I touch on before I wrap this video up, because I'm losing my mind out here. I need to go to sleep. Maybe take some painkillers or something. Anyway, tn-shi once stated in a YouTube comment on a previous piece of music of theirs that they don't really know that much music theory, or don't know music theory at all. It's one or the other. Doesn't really matter which it is. But that just reminded me of a universal truth of music that I've always known, but sort of forgot about. And that universal truth is, you don't need to know music theory, musical theoretical concepts to make music, to make great music. And I've always known this because I cut my teeth on music growing up outside the music theory bubble. I didn't go to music school. I didn't have music lessons, none of that. Well, I had music lessons when I was like 8 years old, but besides that, no. All the stuff I've known about music, I have taught myself, or I've learned through my own exploration. And the little I know about music theory, I also taught myself. I know a little bit of stuff about like classical and jazz harmony, and I know how to read sheet music, and I know how to read and write and count rhythms. That's pretty much it. But I feel like I lost sight of that truth, that music theory is just a way us humans developed to label and categorize and describe and talk about music. And that you don't need to know music theory to make music. It's kind of like any other science, like biology or chemistry or physics. Let's take biology, for example, because that's what I'm familiar with. Biology, the study of life, the study of nature, the study of the environment, all that stuff. Nature exists, whether we exist or not. Nature exists. The plants and animals and microbes and all the other stuff out there in the world exist. And they will be. Doesn't matter what we say about them or how we categorize them. Nature is, and nature continues to be. Us humans developed biology, the study of life and of nature, in order to better understand nature. We're able to put things in all these categories. We're able to label, that's that, and this is this. We're able to develop models in order to explain phenomena and predict what's going to happen in the future. So we've got these categories, and we've got these models, and we've got these names. But nature will continue to exist and continue to be. Doesn't matter if the entire field of biology ceases to exist tomorrow. Nature existed before us, before we were around to invent biology, and nature will continue to exist. Biology is just a way us humans developed to understand and talk about nature and life. And music theory is no different from music. Music theory is just a way we, humans, developed in order to learn and talk about and understand music. So all of this is just to say that in the same way that biology is a study, a science invented by humans in order to better understand and categorize and give names to the phenomena that we see appearing in nature. In the same way, music theory is a study, a discipline invented by humans in order to better understand and categorize and label and name what we see happening in music. But you get what I mean, right? Music theory is one way of looking at things. And you don't need music theory to make good music, to make great music. And so reading that comment from tn-shi reminded me of that universal truth, that truth about music. For a long time, I had been trying to justify all of my creative compositional choices using music theory stuff that I learned about. I wasn't using my ears, I was using my brain. And there's nothing wrong with using your brain. It's just that I like using my ears more. But I wasn't doing that. I was using my brain. I was like, this particular dominant jazz chord needs to have these chord tones in it, and only these chord tones, because this arbitrary set of rules I've baked up in my head says it needs to be this way. Instead of going like, oh, that sounds cool, I like the way that sounds, I like that, I'm gonna use that. That's the way I feel like music should be made. That's the way I've preferred to make music. But for some reason, recently I haven't been doing that. Seeing that comment from tn-shi brought me back to a place I prefer being. So thanks, tn-shi. And also, this song is a banger. Okay, God, I'm absolutely losing my shit here. I need to rest. I need to rest and take some medicine, dude. Oh, God. Okay. Anyway, thanks for watching this video. If you enjoyed it, please like, comment, subscribe. You know the drill. What am I doing here? I'm so sick and jet lagged and tired. I should just end the video. Okay, yeah, I'm gonna end the video. I'm done.